Let's quickly go over how to comp this. Select the camera, go to File, Export Project, Nuke, and choose a location to save the .nk file, the script for Nuke. We save this as a camera script. Okay. And separately, we need to export the distortion. Go to File, Export, and depending on where you're exporting everything, choose the appropriate format. In our case, it's Nuke LD, Lens Distortion Node, which is perfect for Nuke. And we save it as a lens. Also, to make the lens distortion node appear in Nuke, you'll most likely need to download a special plugin kit. To do this, go to the 3DEqualizer website, navigate to the Tech Docs section, find the lens distortion plugin kit, download and install the plugins from there. Here you can see a list of supported Nuke versions. You must have one of them installed. Once the plugin archive has been downloaded, I open it, go into the first folder, then navigate to Compiled, Nuke, choose your operating system, and your Nuke versions. And all of these files should be copied into the plugins folder in the root directory of your Nuke installation. After that, when you launch Nuke, the lens distortion node from 3DEqualizer will be available and will correctly load the distortion parameters. So, in Nuke, we open the camera that we exported from 3DEqualizer. What's in this scene file? It contains the 3D trackers we created. If you go inside the group, you can see each of them and access their positions. There are two cameras. The first is the main sequence camera. The second is the distortion grid camera. Everything created in 3DEqualizer gets exported, so you can safely delete anything unnecessary. For example, we don't need the grid here, and the locators are unlikely to be useful, so we can remove them. Now we import the lens. If you've installed the plugin correctly, it should import without any errors. If there are errors, then you'll need to check what went wrong earlier. Then we bring in the plate as well. I'm not sure it starts from the first frame, so I'll set the first frame manually. What do we do next? We merge our plate with the image from the scan line. But before we merge it, we need to distort it again using our grid. Between the scan line and the image, we insert the lens distortion node with our grid. We switch the direction parameter to distort. You can first demonstrate this just on the plate to understand how the process works. The first node, undistort, unwarps the image. The second node, distort, warps it back. That means there should be no visible difference between the original plate and the chain of two lens distortion nodes. First undistort, then distort. But this approach is not recommended because it means we're distorting the image twice. First unwarping it, then warping it again, plus compositing graphics in between. This puts unnecessary strain on the original footage. The correct approach is to leave the plate untouched and instead warp the graphics directly to match the distorted image using distort. These are locator points. We don't need them right now, because they're more likely to get in the way. And here we can see that, due to the very strong distortion and extremely wide field of view, we get a large overscan image. We'll add that here as well. No need to spare the space. We don't need the locators. Let's just place a checkerboard here instead. We know that this point is our absolute zero, so we can start placing the plate based on it. Our entire plane lies along the z-axis, and by default, the card is positioned at z equals 0, which is exactly what we need. Just like that, we've easily inserted a checkerboard into our plate in comp, fully accounting for all the lens distortions. I hope everything's clear here. Let's move on to more complex distortions.